Okay, on our Chapter 5 test review, number 1 says find dy dx if y equals the ln of the square root of x, all divided by 5 minus x. So you're going to notice we're first going to use our laws of algebra to go ahead and simplify or to uncondense our ln equation. So we're going to go ahead and just rewrite it. So remember that division means subtraction. So here I'm going to rewrite it, so I'm expanding out my logarithmic equation. So I've got the ln of the square root of x, so division becomes a subtraction sign minus the ln of 5 minus x. Now another one of our laws for logarithms says that this power, which is a square root, which is a half power, can come down in front. So now that I've rewritten this, I've got y equals 1/2 ln of x minus the ln of 5 minus x. Now that I've done my algebra, I'm ready to go ahead and take my derivative. So if you remember correctly, the derivative of the ln is just u prime over u. So here I have my constant, which is 1/2. That stays constant. I'm going to take u prime over u. So the derivative of x is 1, and then u would be 1 over x. So that's u prime over u. Now I'm going to go ahead and do the same thing to the second part of my equation. I have 5 minus x. The derivative of 5 minus x is going to be -1. And then that stays all over u, which is 5 minus x. Now I've got 1/2 times 1 over x minus a minus 1 all over 5 minus x. So I go ahead and simplify down to 1 over 2x plus 1 over 5 minus x. And that would be the derivative of number 1. On number 2, it says I got y equals x to the x. You're going to notice this is an exponential equation. So remember, you cannot use the laws of algebra to find the derivative of an exponential equation. I do note that this x right here is not a number. So I cannot use those rules that I have on my derivative sheet. The only way that I can actually take this derivative is to go ahead and take the ln of both sides. So now that I have the ln of y equals the ln of x to the x, now I can take this x and put it down front. Now that I've done that, I can go ahead and use my derivative rule for the ln. So the derivative rule for the ln is u prime over u. So here is my u prime, and here's my u. Okay, now when I come to this side right here, I have to use the product rule, because you're going to notice I do have an equation times an equation. So two separate equations here. There's my first equation, and there's my second equation. So following my product rule, I take the derivative of the first term, which is 1, then I leave my second equation the same. Then I have plus, I'm going to have my first equation left the same. Now the derivative of my second equation is u prime over u. So here's the derivative of x, which is 1, and then u would be over x. Now that I've done that, I can go ahead and simplify it down. So simplifying this down, I've got 1 times the ln of x. It's just going to give me the ln of x. Then x times 1 over x gives me this 1. Now that I've done that, I can multiply both sides by y. So my y is going to come over here. And I end up with y times the ln of x plus 1. Of course, if you'll notice back at the very first, I said that y was equal to x over x. So since y is equal to x over x, I can substitute that into my equation at the very end and simplify it down. So now I replace my y with my x over x, and I get y prime equals x over x, or x to the x, times the ln of x plus 1. And that would be the answer to number 2. You'd have y prime equals x to the x times the ln of x plus 1. Okay, on number 3, it says I've got y equals e to the 1 over x. So just as a reminder right here, I've written, here's my derivative of my e to the u. So the derivative of e to the u is just e to the u prime. So once you know that, it's just actually a matter of taking the derivative of this. So here's e to the 1 over x, so that is my e to the u. So here is e to the 1 over x. All I got to do is go ahead and take u prime. So if I wanted to, I could actually write this out as y, or u equals 1 over x rewrite that as u equals x to the negative 1. Now following my laws of derivatives, I know that's just going to be negative 1 x all to the negative 2, which is going to give me u prime equals negative 1. And putting that variable back down in its denominator and changing that power, I get negative 1 all over x squared. So now I just have to go ahead and put those together, and then I'll have my answer. So I get y prime equals e to the negative 1 over x times x squared. And that will be my answer to number 3. Okay, number 4. It says that I have y times e to the x minus x all equals y squared. So the first thing I do note is that I have this equation is not solved for y, so I'm going to have to use my implicit differentiation rule. My implicit differentiation rule just says every time I derivate something that starts with a y, I have to write y prime. So this is an implicit derivative that I'm taking right here. And I also notice something else. I notice that this first one is an equation times an equation, so I'm going to have to use my product rule right here. So I have to use my product rule on my first set of terms here. So now that I know that, you're going to notice I take the derivative of y, derivative of my first equation, that's 1, and since this is implicit differentiation, every time I derive a y, I have to write y prime, so that's 1y prime. Now I do my second equation the same. My product rule, what comes next is plus. I'm going to leave my first equation the same, which is y, and the derivative of e to the x is just e to the x. Now the derivative of x is going to be 1, and now the derivative of y squared is going to be 2y, and since I just derived something that is a y, I have to write y prime. Now that I've done that, I need to get the y primes next to each other so I can factor it. So you'll notice I'm going to have to solve for y prime. So solving for y prime, first thing I do is I'm going to move this next to y prime e to the x. So when I do that, I get y prime e to the x minus 2y prime. I'm going to go ahead and move this over the other side, so that becomes a minus y to the x, and this minus 1 becomes a plus 1. Now that I've done that, I'm ready to go ahead and factor out my y prime. So factoring out my y prime, so here's my y prime that I'm going to factor out. So I'm just going to be left with e to the x minus 2y. I still have on this side of my equation 1 minus y e to the x. So now to finish this off, solving for y prime, I'm going to divide both sides by e to the x minus 2y to get my final answer. So I'm dividing both the left and the right by e to the x minus 2y. And when I do that, I'm left with my answer of y prime equals 1 minus y e to the x, all divided by e to the x minus 2y. Looking at this next problem on number 5, I notice on number 5 I've got this problem that says I got y equals x to the e to the x. And I need to use the product rule since this is an equation times an equation, but I also need to remember that e is a constant. So since e is a constant, this actually is like x to the 2.7182. So when I actually go ahead and find the derivative of this first one, this is just e to the x to the e minus 1. Then I leave my second equation the same. Now I leave my first equation the same, which is x to the e, and I take the derivative of my second equation, which is e to the x. Now theoretically I could just leave it like that, but there is a common e to the x in all of my equations that I can take out. So you'll notice I go ahead and factor out an e to the x. And when I factor out an e to the x, I get e to the x, and I'm left with e to the x to the e minus 1 plus x to the e. And so I went ahead and factored out e to the x. On number 6, I've got f of x equals the ln of the cosine of 2x. Well, the derivative rule for the ln, remember, is just u prime all over u. So taking my derivative of u prime, so here's my u right here. So here's u prime. So remember, I got to use my chain rule. So I take the derivative of the outer, which is the sine of 2x, times the derivative of this inside, which is 2. Now I'm going to leave u prime the same, so that becomes all over cosine of 2x. So the sine of 2x divided by the cosine of 2x gives me the tangent of 2x. And I still have my 2, that is my constant out front. So my derivative is going to be f prime of x equals 2 tangent of 2x. Okay, now taking this integral, on number 7, it says it wants me to find the integral from e plus 1 to 2 all over 1 all over x minus 1. Notice that this is the u prime over u pattern, because I notice that the derivative of the numerator is 1 less than the derivative of the denominator. So if you want to check it, you can let u equal x minus 1. U prime would be 1 dx. So there's nothing missing there. So this is just a straightforward ln pattern here. So since it's just a straightforward ln pattern, I can just go ahead and substitute this in and rewrite that as the ln of x minus 1. And then I'm going to evaluate it from e plus 1 to 2. So remember, this is going to be f of e plus 1 minus f of 2. So substituting those in, I've got e plus 1, which gives me the ln of e plus 1 minus 1. And now substituting my 2 right here, I've got minus the ln of 2 minus 1. Well, ln of e plus 1 minus 1 gives me the ln of e, and the ln of 2 minus 1 is going to give me the ln of 1. The ln of e is equal to 1. The ln of 1 is equal to 0. Go ahead and subtract those two. So I've got 1 minus 0 gives me my answer of 1. On this next problem, it wants me to find the integral of the secant of 2x. So notice, make sure you memorize all of your integrals of trig functions. In fact, it's probably a good idea just to memorize that entire sheet of all the integrals and all the derivatives. So if you'll notice, this does match the secant pattern, except it is missing a 2. So you'll notice that if you were to use u substitution, this would be u equals 2x. So du would be equal to dx. So all we're missing is a 2 right here. So we offset that 2 by putting a 1/2 out front. And then it's just straightforward, just right off your sheet. You would notice that pattern for the secant. So your answer is just going to be the ln, and you keep the 1/2. So here this constant stays constant. So then the pattern just says it's the ln of the secant of 2x. And notice the 2x stays there, plus the tangent 2x plus c. And that's just straightforward off your memorization. On number 9, it says we've got 19e to the negative t over 5 dt. So on this problem right here, remember my pattern is, if it's e to the u prime, then my answer is e to the u. So that's the pattern. We need to make sure to memorize those. So the first thing I do is I just put my constant out front. So I've got my 19 out front, because I want to see if I'm missing anything for my pattern of e to the u, u prime. So I just move that 19 out of the way. And now that I've moved the 19 out of the way, I'm going to test to see if I have e to the u, u prime. So I'm going to let u equal negative t over 5. I recognize that this is negative 1/5 t. Kind of helps me to understand it a little bit easier so that I know that when I'm actually taking this derivative, it's just negative 1/5. So it looks like my u prime is negative 1/5. So that means that I need to bring in a negative 1/5. So If I bring in a negative 1/5 to offset it, I need that negative 5 out front. So notice, so because it is a constant, so I put the 19 out front because it is a constant. Test for u prime, I found out that u prime is negative 1/5, so that is what I am missing. Offset it with a negative 5 out front. So we'll go ahead and scroll down here, and it says right here, I've offset that with a negative 5 out front. So here's my here's my negative 5 times 19, which is going to be negative 95. So here's my e to the u prime. So since I have e to the u prime, my answer is just e to the u plus c. And then my constant stays constant up front. So my answer is going to be negative 95 e to the negative t over 5 plus c. Number 10, it says I got e to the x over the square root of e to the x plus 1. This one almost matches the u prime over u pattern. The square root sign changes the pattern to regular u substitution problem. You might want to put that in your, and let's see what I write down here. So you might want to put that in your notes. Now we've been studying this pattern quite a bit, and in class what we actually did is we rewrote it like this. We wrote it to e to the x times e to the x plus 1 all to the negative 1/2. So that matches that parenthesis pattern that we've been doing in class together. So I'm going to let u equal e to the x plus 1. So u prime is going to equal e to the x dx. So now using my u substitution with this parenthesis pattern, when I substitute that in, so notice my u, which is e to the x plus 1, so that goes in the square root, so that's u to the negative 1/2. And then this u prime, in other words du, becomes my e to the x. So now going ahead and using the plus 1 from my derivatives, so u to the negative 1/2 plus 1 over negative 1/2 plus 1. This is u to the 1/2 over 1/2. You flip and multiply and you get 2u to the 1/2 plus c. Now you're substituting in my u value of e to the x plus 1. That leads me to my answer of 2 square root of e to the x plus 1 plus c. We had the exact same pattern with the tangent secant on our last test. So just make sure that you go ahead and recognize those parenthesis patterns. Okay, problem number 11. The directions say evaluate this integral. Got the integral of 5x plus 16 all over x squared plus 9 dx. So we're going to need to make this into two integrals since the first term of the numerator power is 1 less than the denominator. That would be your ln pattern. And the second term numerator's power is 2 less than the denominator's power. So you're looking at an arc pattern here. So on this problem right here, we're going to separate it out. We have 5x, integral 5x over x squared plus 9 dx. And then we've got the 16 over x squared plus 9. So this first pattern is going to be our ln pattern. So I'm going to go ahead and take the 5 out. And then I'm going to set u equal to x squared plus 9. When I take the derivative of u equals x squared plus 9, I get u prime equals 2x dx. So I'm missing 2 to complete my pattern. So I'm going to go ahead and put in my 2. And when I put in my 2, I need to offset that with this 1/2 out front. Now it matches the ln pattern. The ln pattern which says I have u prime all over u. So if I have the integral of u prime all over u, my answer is just the ln of the absolute value of u. I still have my 5/2 out front. Here's my u prime over u. So match the ln pattern. So now I've got the ln of the absolute value of x squared plus 9. Of course, I don't need the absolute value because of the x squared. That will always be positive anyway. But I'm just going to leave it in there. Okay, now I'm going to go ahead and check this other pattern. So my arc pattern here, well, with the arc pattern, I go ahead and take that 16 and put that out in front. So here's my 16 and put it out in front. Now I'm going to check to see how it matches up with the pattern. So remember I let u squared all equal x squared. So that means that u is going to equal x. I let my a squared equal 9, so a is going to equal 3. Now I go ahead and check to see how well that matches up with the pattern. So here's my derivative of u equals x. So that means that du or u prime all equals dx. So it's not missing anything to match the arc tangent pattern. I still have my 16 out front, and I leave my 1 all over x squared plus 9. Now that that matches the pattern, I just have to remember what the pattern of the arc tangent is. So the pattern of the arc tangent, I still have my 16 out front, and you remember the pattern of the arc tangent says that I'm going to have this 1 over a out front, and then the arc tangent of u over a plus c. So that matches up that pattern. So my answer to this problem is 5/2 the ln of x squared plus 9. That first problem was the ln pattern. And now the second part of it was the arc tangent pattern. So I have 16/3 arc tangent of x over 3 plus c. Now number 12, I've got y equals x cubed times the square root of 2x plus 3 all over x minus 2 squared. It says to use logarithmic differentiation to find the derivative. So to using logarithmic differentiation, I'm going to take the ln of both sides. Now that I've taken the ln of both sides, I can go ahead and use my algebra to go ahead and expand out this equation here. So I have x to the third plus the square root of 2x plus 3 all over x minus 2 squared. So if you remember from your algebra, we know that multiplication means addition. We also know that division means subtraction. And we also know that all these powers can go out front. So that's what I'm going to do is I'm going to use my algebra to go ahead and expand out my equation to make it a little bit easier to work with. So here I've got my x cubed. It's going to go out in front. I still have my ln of x right here. And I've also got times right here, which means plus. And now this square root is actually half power. So that's also going to go out in front. So here it is out in front. Now I have the ln of 2x plus 3. And then this division means subtraction. And my 2 goes out in front. So expanding this equation out using my algebra, I now have the ln of y all equals 3 ln of x plus 1/2 ln of 2x plus 3 minus 2 ln of x minus 2. Now that I've done that, I'm ready to go ahead and differentiate it. So if you remember correctly, the ln of u is just equal to u prime over u. So here I've got the ln of x. So here's my u. Derivative of x is 1. There's my u prime over u, 1 over x. 3 is my constant, so it just stays the same out front. Here's 1/2, which is my constant, stays 1/2. I take the derivative of 2x plus 3, which is 2, u prime over u, so that's 2 over 2x plus 3. Here's my constant, stays constant. The derivative of x minus 2 is going to be 1, and then u prime over u, 1 all over x minus 2. And notice over here, same thing, u prime over u, so that's y prime all over y, u prime over u. So now simplifying this down a little bit. So I'm going to move this y over here. 3 times 1 over x becomes 3 over x. These 2's are going to cross out, and so I'm just left with 1 all over 2x plus 3. And then I'm left with 2 times 1 over x minus 2 becomes 2 over x minus 2. So now simplifying it down further, I know that y was equal to this equation right here. So notice y was equal to x cubed times the square root of 2x plus 3 times x minus 2 squared. And then I still have my 3 over x, my 1 over 2x minus 3, and minus 2 all over x minus 2. And we'll just leave it like that. We could combine it together using some algebra, but we'll just go ahead and leave it like that. And that would be my derivative. Okay, on number 13, I've got the integral of the tangent of 3x. So once again, make sure to memorize all your derivatives and integrals. This one matches exactly, except it is missing a 3. So notice if I just let u equal 3x, so that would mean that my du is going to equal 3 dx. So here I'm missing my 3, so I put that out front. Or sorry, I put that next to my tangent to offset it. I put that 1/3 out front. Now that it's matched up, make sure you have these memorized. Just straightforward memorization one. So we end up with negative 1/3 ln of the absolute value of the cosine of 3x plus c. On number 14, this is actually a pre-calculus problem. It says we've got 2 to the 3x minus 1 all equals 5. So remember the opposite of a base 2 is log base 2. So I'm going to log base 2 both sides. When I do that, this crosses out. I'm just left with my 3x minus 1. Now log base 2 of 5, I'm going to use my change of base formula. So remember my change of base formula is log 5 all over log 2. You can also use the ln. That would also work with your change of base formula. So the ln of 5 all over the ln of 2. Either one works. So now I'm just going to have to go ahead and finish this off by dividing by both sides by 3. Now when you're done with that, you just go ahead and put that into your calculator. So putting this into our calculator, let me get my calculator up here. So just move it over here. So on your calculator, let's go ahead and clear this out of here. So we're going to go ahead and take log 5. Now we're going to divide by log 2. I hit enter, and I hit plus 1. I hit enter again, and I'm going to divide all that by 3. So it looks like that answer comes out to be 1.10730935. So I just go ahead and round that off. And that is going to be my answer. So 1.1073. On my last problem, number 15, says I've got y all equals x cubed divided by 3 to the x. Notice I'm going to use my quotient rule. And don't forget what the derivative of 3 to the x is. So remember that that is one that you use on your memorization sheet. You can work it out the long way, but it's best if you have these memorized. So the derivative of the first equation is going to be 3x squared. Now leave the second exponential equation the same, 3 to the x. Next comes my minus. Now I'm going to leave my first equation the same, 3 to the x. I'm going to take the derivative of my exponential equation, which is 3 to the x, and it's also times the ln of 3. Now this is going to be all over the denominator squared. So the denominator squared is 3 to the 2x. Now that I've done that, I notice that there is a common 3 to the x term in all of those. So let me scroll up just a little bit. So I'm going to divide all my terms by 3 to the x. So I'm going to divide this term by 3 to the x. So it's common in all 3 of them. This term by 3 to the x. And also my bottom term by 3 to the x. When I divide this by 3 to the x, that cross out, I'm just left with 3 to the x squared. When I divide this by 3 to the x, I'm just left with my x cubed and my ln of 3. And now this denominator, I got 3 to the 2x divided by 3 to the x. Remember, you subtract your exponents and keep the same base. So 2 to the x minus x is x. And that would be your answer to number 15. 3 to the x squared minus x cubed ln of 3 all over 3 to the x.